Hello, good morning, good afternoon if you're in New Zealand, and good morning if you're on the west coast of Australia or in Indonesia. Welcome to Motion and Australian Timken's webinar on fixed plant applications. Um, this webinar, we will have a quiz. So within the quizzes, use the chat, and then at the end of the presentation, we will have a Q&A section. So without further ado, let me introduce Mark, who's from Australian Timken. Mark is the National Mining Manager, over 27 years experience within the bearing industry and 10 years specialising in mining applications. He has extensive experience, not just in mining, but also sectors supporting the mining industry, and is very much focused on improving equipment reliability and performance. My name is Fabio Rebecchi. I'm from Motion, and I am the product manager for industrial bearings. So, Mark, welcome. Thank you once again for doing this with us, and over to you.
Thanks, Fabio. Good morning, everybody. Good afternoon. So this presentation, we're going to talk about three main topics that you're going to see that are very common applications in both quarries and in mining as well. Those being rock or ore crushers, conveyors, and vibrating screens. So with the crushers, what type of crushers do we see commonly on these both quarries and mine sites? Typically, we see two different types of crushers, either the compression style or the impact style. And compression crushers are probably way more common, certainly jaw crushers, and we'll see those on most mine sites as what we call a primary jaw crusher to crush the rock down. So once it's been mined, it has to go into the processing plant. And to be able to transport it around that processing plant, they've got to crush it down to a consistent size. And that's why you use crushing systems. Commonly, you have jaw crushers as the primary crusher, and then it moves on to secondary and tertiary crushers as well, which are commonly cone or gyratory crushers. On the impact crushers, these are a lot higher speed. It's designed to run with a fast turning impeller, which impacts the type of ore. And it really depends on the type of rock that they're actually crushing and the type of how hard it is, and also what type of ore. So the rock that is containing the target mineral or metal, or whether it's just like a quarry that is just crushing a rock down to a certain size for its different applications. But commonly we will see vertical impact crushers or VSI crushers in quarries especially. That's becoming quite common now as a very good tertiary or secondary crusher. So the reason why they break it down into primary, secondary, and tertiary is to basically to size that rock once they crush it. So a primary crusher, as we'll see in the next few slides, is quite it's the output of that crusher is still quite rough, and it comes in different sizes. Whereas a secondary crusher is a different type to actually process that rock down into a more consistent size, and then it allows them to process it or transport it on conveyors at a much easier process. And then tertiary crushers are then designed specifically for really getting a very even and consistent size, if that is needed in the actual primary or the finished product of that quarry. But some types of crushers can be used for all three stages, and as in cone crushers, but jaw crushers are only ever used for that primary and secondary stages. So when you have compression crushers, again, they're very good for those initial stages of breaking down the ore from a large size. And some of the mine sites can, when they blast, they'll transport rocks the size of washing machines basically to the mill, and when it arrives at the mill, the first piece of equipment that rock has to go through the into the crusher. So the jaw crusher or the impact crusher has to be able to accept rocks of varying sizes, to allow that to actually get in and start that process of breaking it down to a more manageable and more transportable size. So this is a jaw crusher, little animation on the side there. Basically, it shows that you get different size rocks that come off the feeder, which is a vibratory feeder, which we're going to cover a little bit later. And as it goes through past the fixed jaw on one side and then the rotary jaw or the pitman, it's starting to crush down, and it gets basically the throat or how much the size the physical size of the throat of the crusher is what sets the jaw crusher size. And this is a 24 by 36. It's just 24 inches by 36, so it's a rectangle shape on the top there, which can physically fit a rock down. And then as it gets forced down, the rotary action basically fractures the rock, and then the crushed rock that comes out of the crusher is a variable size, but it can't be any bigger than the actual bottom of the crusher there at the bottom of the V. Note that you'll always have flywheels. So these heavy metal flywheels gives the inertia to actually crush the rock. So when a larger rock gets jammed into the crusher, the jaw still has the inertia to continue on moving and actually crush and fracture that rock down. And you'll have one flat. The OD of the flywheel is flat on one side, and the other side, you can just about see there, has V grooves in, because these are belt driven, and very, very large angle of wrap around the crusher, which gives a large amount of grip for the belts to drive these crushers. Jaw crushers come in different forms as well. Commonly in quarries and smaller mine sites, you'll see mobile crushers. In quarry sites, this is a very good solution, because it allows the crusher to move around the mine, so they don't normally have to have a huge amount of dump trucks, so they can literally blast a section of the quarry, move the mobile crusher across to that point. And then with an excavator, they can basically dump straight into the feeder, the hopper, then into the vibrating feeder that then goes into the jaw crusher itself. So they can produce a finished product in some quarries, whereas depending on the rock type, straight away from the actual mined area, instead of having to have a transportation system with dump trucks or smaller trucks taking it away. So you'll see a lot of these. You also get vibrating screens on mobile equipment as well. So this could be basically daisy chained onto a mobile vibrating screen sitting here, and that will then sort the crushed rock into different sizes, as we'll cover a little bit later in this webinar. But it allows the quarry to have a very flexible system, and it's quite common these days. Gyratory crushers are a little bit different. So they're slower moving. They rotate. They've got a drive shaft coming in the side here. And this cone, actually, the blue cone section, does rotate around as well as gyrate. So it's on an offset from the main shaft. And that gyration action crushes the rock as it falls down in between the fixed cone and the rotating cone. And this gives you a very consistent crush size, and hence the reason why they're primarily used in secondary and tertiary crushers. But in some very large sizes, they are used as primaries as well. But they're normally used in a primary situation like this, where the dump truck is dumping straight into the cone crusher. You can see the different size variation from very, very fine gravel all the way through to large boulders. And it's whatever can fit down that chute and then into the actual throat of the cone crusher there. Now, in this case here, they're using a rock breaker, a hydraulic jack to actually crush up any and break up any larger boulders that don't physically fit into the crusher, which they'll do automatically from the operation booth here. But you can see the size with the two maintenance guys here, the size of these. Commonly, if it's used as a primary crusher, it's actually used as a multi-stage. So there's actually more than one crusher sitting on top of the other, so two or three, which then gives that much more consistent output from the crusher once once it goes through all three stages as such. It's not as common. Some very, very large mines like iron ore mines will have these, but certainly not particularly common in the hard rock and certainly not in the quarry systems. Yeah, you won't see those. Different type of crusher is a impact crusher. As I said before, is the vertical shaft impact crusher, the VSI crusher. This is a Mezzo Barmac design. These are one of the first ones that came out. And the way it works is it's rotating this through this barrel here. The shaft is rotating and turning this impeller at high speed, about 1,000 RPM. And the way that works is 2/3 of the ore flows through the center of the crusher, and then you get a certain amount flowing around the outside, which then causes the ore in the center to hit the impeller. It gets flung out with centrifugal force at high speed, and that impacts the rock going around the outside of the crusher, and it's basically a rock on rock action. So it's using the speed of the rock and the inertia of those rock particles to actually break the rock up, and it does produce a very consistent rock output. Belt driven, two large electric motors, belt drive on the bottom. So there's some opportunity there as well for different supply of those parts. But it's a very high throughput as well. So you can put a large volume of product through there, and it will give you a very consistent output and a high volume output. So just the first question, Fab, if you want to do that.
Sure, absolutely, Mark. Thank you. So just remember to use the chat in this instance. So what stages of crushing are there? It's a multiple choice, primary, secondary, tertiary, all of the above. So I will give 10 seconds, 10, 15 seconds, wait for some answers to come in. Don't forget the chat is where we're using this. Okay, I can see quite a number of answers come in, and yes, D is the correct answer, as we can see now highlighted. Thank you, Mark. Thank you for everybody else participating.
So in conveyor systems, again, once we usually go through a crushing stage, we're now able to actually move the product around on conveyors. And bulk handling conveyors is what we're talking about today. Also commonly known as trough conveyors as well, because the product doesn't sit on a flat belt; it sits on a trough. So the standard layout for a conveyor, you've got the different the single direction of travel. So in this case here, you'd have the product being loaded onto the conveyor through a chute at the tail or the rear of the conveyor, and then the direction of travel is uphill. In this case, it's an elevated conveyor, which most conveyors would be, and it moves up to the head, and then basically at the head, when it gets to the end of the conveyor, all the ore just flows off the end, and that goes into another chute, or it goes into a different stockpile. It's depending on what they want to do with it, but they all have the same layout. So normally, if it's an elevated conveyor, as this one is, so it's lower at the bottom, higher at the top at the head end, the conveyor is the drive is always at that head end, so it's pulling the product up the hill, not trying to push it. And you'll notice that there's a number of what we call pulley drums. So the pulleys is where the belt changes direction. So there's a number of pulleys on here, both the tail, the head. You've got bend pulleys where it's just literally a 90-degree change of direction. And then you have a take-up pulley here, which is a gravity take-up. So you have a large concrete or metal mass sitting underneath on a trolley system, so it can actually stretch the conveyor belt. And the stretching of the conveyor belt gives the traction around the pulleys that actually allows it to drive on the head pulley. So this is a rubber lagged or ceramic lagged, which is a lagging is the outside cover of the pulley. So it's rubber on rubber or rubber on ceramic, which actually gives a very good positive drive to the conveyor belt. Now, the conveyor belts are usually steel cord, so there's a wire cable, series of wire cables inside the V belt to give the amount of the tensile strength that they need to be able to drive up. And then on the top of that, you've got what's called the trough idlers. And the trough idlers are three idler rollers, so one at the bottom and then two on what they call the wings. And that just holds the conveyor in a V form and allows the product to stay inside the conveyor. If it was a flat belt, you'd end up with all the product flowing off the sides of the belt as it moved up. So your your V belt or V trough shape allows the product to get from one end to the other and staying in the same center of the belt there. On the bottom of the belt, you'll see there's what we call return idlers. So they're spaced out a much more larger spacing. This obviously on the trough has to carry the weight of the product that is on the belt. On the bottom side, the return side, it's not as heavy because it's just literally the weight of the belt itself. So obviously for our industry, the conveyor belts are a good target application. There's lots of different products that we can sell in that, and both in the housed units as well as the electric drives and couplings and also gearboxes. So the problem with conveyors is they also get highly contaminated, and one of the issues that we come across all the time is trying to keep the contamination from getting into the housed unit. And it's really, really a very dirty application. It's very fine powder as well, so it causes all sorts of problems with the sealing arrangement. It penetrates through that sealing arrangement quite easily. From a theoretical point of view, the L10 or the theoretical life of the bearing, the spherical roller bearing that's on inside these housed units, should be very long because the sphericals are loaded very lightly, because the design of the conveyor is based on the shaft deflection, how much load, how long it is, how much deflection that the shaft will give, and usually what that means is the shaft diameter is quite large, and then they select the bearing size for that shaft diameter. And in my experience, we've had quite an issue with different bearing manufacturers producing sphericals that will take more load over the years, and actually it becomes a problem with potentially with roller skidding because the bearing's just not carrying enough load. But the main thing that kills conveyor bearings, conveyor pulley bearings, is contamination. So almost every mine site and quarry will do some sort of washdown procedure, which is part of their housekeeping to keep the plant clean and wash all this dust off. And they quite commonly do push water into the seals and push contaminated products. So very, very fine rock dust, coal dust, any type of fine powder that gets pushed in through the seals. It wears the seals out, and then you end up with issues with the lubricant getting contaminated with rock or with water or both, which causes problems with viscosity, and also you can have problems with if the housekeeping isn't very good, you can get large volumes of dust building up over the housed unit and insulating that as well, which also has problems with low viscosity then. So you can get once you do get that product into the housed unit, then you end up with a lapping paste inside the lubricant with that fine rock dust, and that then grinds material away, and you end up with excessive clearance and damage to the cage. So you quite commonly end up with cage failure as one of their primary failure modes. So how do we seal that? Is there any way we can stop it getting in? Not really. There's all sorts of different types of seals on the market. Some very basic, like just a simple double lip grease seal. Others like the more common taconite type seal, which gives you a labyrinth to stop the pathway or slow the pathway of the material getting in, the contamination. It also gives you a purge, so you can actually push that contamination out with the fresh grease, and then gives you a physical seal, in this case a V-ring seal as well, which is a good option by most industry standards. That would be the most common type of seal on quarries and mine sites. The problem with the V or the double lip type seal is that it's shaft wiping, and of course we know that there's going to be damage or sorry, contamination on that outboard side primarily, and that's going to start grinding the shaft. So we don't want to damage the shaft if we can. So a labyrinth or a taconite seal is a good option. So it's not shaft wiping; it doesn't damage the shaft, and it can be replaced separately if needed. But the problem with just a labyrinth is it's an open pathway, so contamination, especially if you force it in with the water or with a fire hose and start spraying high pressure water at it, it will force contamination in. Very effective at high speed, like a fan speed, but not at conveyor speed. So a labyrinth only is just not really an option for. So these three would certainly wear out fairly quickly and not really seal properly. A physical barrier like an end cover, obviously for a housing that doesn't have the shaft going all the way through, that is a good option. But it's it's a physical barrier. It's not rotating, so it's not going to actually leak or anything. But certainly a taconite type seal is a good option. And then, depending on the type of housing that you're using, whether if it's one of our solid blocks, the Timken solid blocks, these would be all split housed units, so SNT types or an SN series. Whereas this one here is a solid block or more of what's called a plumber block. And they have a different type of sealing arrangement where the primary seal runs on the inner ring of the bearing. So again, not shaft wiping, runs on a hardened steel surface, which is a ground, so it gives a very, very effective seal. And then on top of that, you can actually add external covers as well, just to give more further protection. So this is again, in my experience, this is an extremely good off-the-shelf solution for improving sealing capability. And if it's a split type housed unit, so a split cylindrical, that gives you other options as well with split to the shaft options. So you can basically build the housed unit around the shaft, and there's different types of sealing capabilities there that we have, from labyrinths all the way through to Kevlar packing seals and things like that, which don't damage the shaft. So really, from an engineering perspective, the key thing is to keep the contamination out of the bearing. So if you keep the grease inside the bearing as clean as possible for as long as possible, that's going to give you the best solution, and it's going to give you the longest life in service. And it's even to the point where adding grease into the housed unit can contaminate or add contamination into the housing cavity as well. So it's a matter of being careful and keeping the grease nipples clean, with the caps on, the little plastic caps that protects and clean and keeps the actual grease nipple clean, and then take the cap off, put your grease in, and then close it back up again. But again, in this solution here, because it's a solid block housing, it's pretty much a sealed spherical inside. It's got two seals that are basically adjacent to the housed unit, to the bearing, and it basically has very little volume inside for grease. So the re-greasing need is much lower because we keep the lubricant clean as possible. So you can see there the recorded savings of $12,000 over a 12-month period. So it's a very effective way of doing that, and it can be then multiple applications across site can have the same solution added to it. And those solid blocks through Motion have been in service, and there's hundreds and hundreds of them in service around the country in different quarries and mine applications.
Thank you, Mark. Okay, so question number 2, drive, bend, tail, and take up are names for which common components on a conveyor? So A, pulleys or pulley drums, magnetic conveyors for B, and C, pneumatic conveyors. So I'll give a couple of more seconds. I can see a number of answers coming in at this stage. Yep, looks like everybody so far has the correct answer. And the answer is, if you can highlight it, Mark, A, pulleys. Thank you.
Thanks, Bob. So vibratory screens, or screens as they're commonly known in the industry. So if you went to a mine site or a quarry and you asked the customer and the operator what type of screens do they have, they're going to come up with some different answers and some different terminology. And basically, a vibrating screen is just a method of being able to either sort product, so it sorts size through a series of what they call decks or levels inside the vibrating screen. So that's a deck, a second deck, and then a third deck on the bottom. Or it's used for dewatering as well. So it basically shakes the water off a product, so it dries that product off, and that's used commonly in the coal industry when they're washing the coal. So they're trying to basically wash all the water off it. Wash all the impurities off it that they don't want, and then they shake the water off so they're not transporting large volumes of water that they've got to then remove later on. But they're basically belt driven. Commonly, this one's a dual shaft. So the shafts, when you look at the cutaway, the shaft has an eccentric section, which allows causes the screen to bounce up and down when it's in service. And these run at fairly high speed. And again, the speed is controlled by the belt drive, which then gives the amount of movement of the screen that is required for that particular operation. So that whole deck, that whole machine bounces up and down on that series of springs. And when you've got a whole series of these, you can put them in like side by side. If there's a big volume, like on an iron ore mine, you might have 8 screens all sitting next to each other, all sorting product. And that's a large amount of vibration. You'll feel it in your chest as you're standing there because of the amount of air that is physically moving around. It's like being at a concert, so you feel the shockwave from it. So there's 2 different main types of screens. There's either vibrating screen, as in sorting screens, or feeders. So a feeder is one that just has these either vibrating rollers or vibrating rails, in this case, like beams, and that they're used to actually feed product into a crusher. So you'll see them every primary crusher will have a vibrating feeder that is feeding the rock, and it basically advances the rock into the crusher, into the throat of the crusher, and that is on every mine site you'll see a vibrating feeder of some sort. So that's exactly the same as far as the bearings go. It's the same type of bearings and the same specification of bearing as it is for the sorting screens. So on this screen here, on the picture of this, this is a mobile screening plant, and you can see that it feeds into that's the red section at the top is the screen, and the output has multiple outputs. So it has this conveyor that is feeding out a particular coarser grain product. And this one is a finer grain product because it's a multi-deck screen. So these quite often are the primary, basically the finishing size. So they'll then use a wheel loader to come in and dig up that stockpile and then put it onto a truck, and that's basically on a quarry. That is their finished product, is just different gravel sizes, and it could be as big as your fist if it's for ballast for a rail line, or it could be very, very fine, like crusher dust is almost a byproduct of crushing, but it's very, very fine, and it's used in quite a few different applications because it can be compacted really, really hard. So the way that the screen works is through the medium or the deck that is sitting on the machine. Product of different sizes is fed in. Anything that doesn't fit through the holes in the deck will basically pass along the deck and fall off the bottom of the deck to be reprocessed again. Anything smaller than the deck, the hole size in the deck, will actually fall through, and it's then sorted. So this top section here will go through for reprocessing. Will probably usually be fed back into the secondary crusher, and then sent back to the screen again, so that it that becomes a uniform size after a period of time. But that bouncing action of the screen forces the product to basically just walk down the screen. And commonly, screens are angled, so they're inclined to actually aid with that process. If it's a dewatering screen, it's probably more often than not, it's horizontal like this picture here. And it basically is just designed so it shakes off the maximum amount of water before it gets to the end of the screen. But commonly, you'll see most of them. And if I go back one screen, you can see how that's inclined, again, to feed the product down the screen and feed it off the end. You can see on this one here, this is you get dual shaft. You can get single shaft screens. You can get triple shaft as well from Cedar Rapids. They're the only ones I believe that make a triple shaft. And in this case here, it's also you get a single, double, and triple deck in this case as well. So it's going to screen out 3 different sizes of product, plus the overflow as well. So it's really a quadruple. So can be quite high speed in the drives. So again, there's plenty of opportunities there for bearings, and they have to be of a particular specification. That's the key thing on a vibrating application. You'll also see ones that have gearboxes sitting on top, the vibrating screen mechanisms they call them, and they sit on top and they basically just bolt a number of screens. Can be one box, can be 2 or 3 boxes on top of the screen, depending on the application and the weight of the product that they're actually trying to screen as well. So there's a big difference between screening coal compared to iron ore. Iron ore has a much heavier product, so it's a much larger screen normally, and more mechanisms to make the screen bounce that amount that they need. But the bearings are really critical. You cannot put a standard spherical roller bearing into a screen. It's the wrong specification. It will get damaged very quickly, and it will only last a number of hours. But commonly in Australia, we use the 223 series and 233 series, but by far most common is the 223 series. So when we actually specify a bearing to fit onto or be used in a vibrating application, we control different parts of the design, both from the cage and also the inner ring design, but also it's the dimensional control that we have to put onto the bearing to make sure that it works in that application. Occasionally you'll see cylindrical roller bearings, but they're very uncommon. There are some applications that do use them, but there's not many at all. So you'll see screen bearings as in spherical roller bearings most commonly. Oops, sorry.
Okay.
One part of what we control is both the inner ring dimensional tolerance and also the outer ring dimensional tolerance, because that's really important to make sure that we do not damage the screen when we put it in. So let's go to the question, and then I'll move on to the bearing side.
Thank you, Mark. Okay, question number 3. What are the main bearing types used for a vibrating screen? A, spherical roller bearings or cylindrical roller bearings. B, ball bearings or noodle roller bearings. C, spherical plane bearings or angular contact bearings. Okay, I can see the answers coming in, so we'll give a couple of seconds. Sure, we can see. I've seen all the right answers, so memo to myself, make the questions a little bit harder. And the correct answer is A, spherical roller bearings or cylindrical roller bearings. Thank you.
So damage modes that we get with screen bearings is, again, contamination. We get contamination being pushed into the screens when they're doing the washdowns. All the seals are starting to wear. Again, it's a higher speed application, so the seals do wear out faster. Again, we get lubrication. It becomes more like a grinding paste or a lapping paste, and it gets that hard particle, very fine hard particle in the lubrication. So it does cause issues with fine grain spalling. and we have normally you'd run a screen at about 80 degrees, maybe to 90 degrees centigrade, depending on the ambient. So they, because they're running faster, they do run at higher speed, and the application destabilizes the rollers because it's shaking so violently that it does generate more friction as the bearing is in service. So you do have issues with lubricant viscosity as well. So you also have threading issues as well. So that in an application, the in a vibrating screen, the outer ring is the tight fit. It's a very heavy tight fit to actually stop it from rotating, and so you do, if there's any damage or wear to the screen housing, the part of the where the OD of the bearing fits in, you will end up with initially threading corrosion, which is an indication that the fit is becoming overcome. So it's starting, the bearing is starting to move in the bore, but then if it gets to the point where it actually does rotate, then you're going to get a lot of heat generation, a lot of expansion of the bore, which is going to loosen the fit, and you'll end up with more and more rotation. So once you get that, then you're going to burn the bearing out. So you should be able to get 3 to 4 seasons out of a thing, or we probably call them 3 to 4 years bearing life. But commonly, 12 months is pretty common, because most sites have issues with worn and damaged shaft and housings that should be replaced or repaired, but they don't actually get that done. So. And we can run tests. We have our own test machine. This is a Timken test machine. You can see there's a mechanism on the top of this orange section. That is the vibrating mechanism that basically shakes the screen, and we can basically run tests depending on the type of design that we put in there. But the main thing that we get is we get an extension in life, simply because we can get a cooler running bearing. So if we get less temperature, we get better viscosity control, and that gives us the ability to get an extension in life. So fewer oil changes as well. So you're not, in the case of a mechanism, they run in oil. If it's a shaft, a double shaft or a triple shaft, they'll normally run in grease. So if you can reduce the amount of lubricant replacement, then we're going to get a better overall life as well. Excuse me. So really, with sphericals in vibrating screens, the challenge, the design challenge, is always to see how cool we can run them, but allow the load, increase the load rating of the product to actually get longer life as well. It's Q&A time.
Excellent, Mark. Thank you. So just for the audience, just to recap, don't forget to there's a separate Q&A section. We do have a number of questions that have come in, Mark, so we need to have our thinking caps on here. So I'll look at those and read them out, maybe in order they came in. Give you a little bit of time. I'm not sure. Can you see the questions, Mark, at all, or no?
Yeah,
Well, the first one I'll read out is, what are the most common failure modes you've observed, specifically with split cylindrical housed units? And to what extent are these driven by design limitations versus installation or general maintenance practices?
so with split
Good question.
cylindricals, yeah, it is a good question actually. For split cylindricals, you have a bearing that is split on the inner ring, the cage, the outer ring. So there is an inherent issue with the rolling elements passing over that split, but the design of the bearings is such that the roller doesn't strike that split section in one piece. It's a V shape on the inner ring and the outer ring that stops that rolling element just striking that split. The tricky part with setting up the split cylindricals is making sure those gaps on the inner ring are actually even when you clamp it onto the shaft. So it does in some way rely on the shaft being in good size. So it still has to be a H9 fit, same as a sleeve adapter sleeve. It still has to be at the right same size range for that. But if you get that set up correct, where you end up with the two halves of the inner ring with an even split, you should get good operating life out of them. And some people see splits, especially in conveyors, as a bit of a band-aid sort of fix,
Hmm.
but they're not. They can be put on from new, and a lot of some OEs do use them as um, the design that they go with, and certainly for fans, they do get used as an OE spec as well, so that they can have a long life if they're set up correctly. But predominantly, it's a setup issue, but that can be trained. That's part of our role to make sure that both Motion and the end users are understanding the product that they're using, which we do on a regular basis. We go out to site and do training. So, but
Right. So you'd say not so much a limitation by design, more so of maintenance practice or installation practice.
yeah, exactly. I mean, the
Okay.
maintenance really shouldn't make it a lot of difference. It's a self-aligning product. The bearing doesn't self-align. It's a cylindrical roller bearing, but the housed unit allows for self-aligning. So you'll still get a good life out of them. And they're commonly used on tracked applications. That's the predominant use. So a trapped application where you don't have to move the pulley or the gearbox or the coupling, you can leave all that in position, cut the old bearing off, and then apply build the split cylindrical around the shaft, which gives you a much shorter downtime, but it is a good solution for permanently be left in there. Yeah.
Okay, so I'm gathering a bit of a theme here, scanning the questions. The next one I'm thinking is related once again to a split bearing. Uh, when customers push back on higher upfront costs, how do you quantify the total life cycle benefit, and in what and in a way that resonates operationally and not just in a theoretical sense. So, what do we show? Actual examples in the field historically that we've seen. Um,
And the big thing for the mine site or the quarry is downtime. So if you can save a number of hours or days of downtime just for doing a bearing change, the actual upfront cost of the product, the housed unit, is absolutely minimal and just shouldn't really come into the equation. So if you, for instance, if you have an elevated conveyor on top of a
mhm,
large stockpile, first thing you've got to do is put a dozer in there or a number of dozers and flatten the stockpile so you can drive a crane up so you can actually lift the old pulley and the drive off, lift off the gearbox and then the pulley. That normally takes days. So if we can build it in situ and don't need a crane at all, if it's a small enough housed unit that can be carried up there, that it's going to save tens of thousands of dollars just in downtime. It could be even hundreds of thousands if it's a big mine. So yeah, it's really, if you get pushback on purely just on the cost of the product alone,
mhm.
then yeah, you need to look at the total solution and what the actual the cost of the downtime is.
So there's two aspects there. There's one, the downtime, and then there's the actual cost of doing the job, where you may have to bring on board auxiliary equipment such as a crane, etc. Okay,
Exactly. Yeah. Yep.
okay, and that would be quite clear for the client to see that if you were to highlight that correctly. Okay.
Yep.
Um, can we get training on this? Well, that's a good question also. Training is available by Motion and Australian Timken. We can do joint training, we can do individual training, we can do theoretical training, we can do training on site. So do get in contact with Motion Australia at your local contact, sorry, and training can be organised, whether it's in class, on site, via webinar. There's lots of options that we have available. Um, so let's, Mr. Anonymous or Mrs. Anonymous, what your training specifics are, just highlight them to the Motion team, and we'll look at what we can provide for you. Unless you
Yep.
want to add something else there, Mark. We can do factory visits if you're willing to do all that type of training. We can go from very
But,
simple training right to very in-depth, almost university qualified
yeah,
training.
we've got our service engineers that travel out to site regularly. Just had I know it's a different industry, but on the cotton industry in the cotton gins, going through and fitting split cylindricals just recently. As of just last week, actually. So yeah, that's available. We can go out there, and quite often sitting through a PowerPoint presentation for the fitters is not as relevant, and they can understand it much better if you physically see it. We have demo kits as well, so we can actually show. We can come to motion branches and do demonstrations on how to fit them. So the staff at the motion branch has got more confidence to talk about and talk to a customer about that on the counter. But we certainly can be on site and oversee some the fitting of the actual application. And that usually is by far the most effective way to train the fitters to fit the bearings correctly. Yeah.
A couple more questions to go, Mark. So, what housing for shaft misalignment is acceptable on a conveyor pulley bearings with tack seals?
So whilst a spherical rolling might have 1.5 degrees or 2 to 2.5 degrees of misalignment, depending on the size of the and series of the spherical, it's really the amount of misalignment that the tack seal can take, and that's usually only 1.5 degrees max. There are some modified versions of tacks that in the marketplace that can take more, but you're really limited by the amount of the misalignment basically between the labyrinth. That's what limits the actual whole housed unit misalignment capability. Unless you use a split cylindrical, or you're using what we call an self-aligning E-type tapered roller bearing, which is a double tapered roller bearing housed unit. Those self-aligning capabilities are more in the 4 degrees misalignment plus or minus. So they're very large because the whole unit misaligns inside the support. So that unfortunately the limitation on the spherical is actually caused by the labyrinth. Yeah.
Right, and not the bearing itself, yep, not the spherical roller. That's a good
Yep.
point. Some people just think, oh, spherical roller bearing misalignment, 1.5%, for example, well, we'll be fine. But look at the componentry within the housing. There'll be some other
Yeah.
limitations that they may have. So
Yeah. And
keep that in mind.
if you do misalign the labyrinth too much and it binds, then it generates a lot of torque, but it also generates a lot of temperature as well, and really cause some problems, and it will wear quite. It's cast iron, but rubbing against cast iron, and it'll just whilst it's got lubricant in there initially, it'll probably burn that out pretty quickly. So.
Okay. Another question here. What kind of practices do you recommend to minimize bearing contamination by seals? Are there specific maintenance practices that can be utilized above and beyond the actual seal design or the seal type?
Yeah, the key thing is making sure the seal goes in the correct orientation. So making sure that the spring, the garter spring, is visible on the outside, so that stops the contamination pushing in underneath the seal. So again, if you're using tandem seals, so two seals, one seal is sealing the lubricant inside, so that would have the spring facing inwards, and the exterior seal would have it facing outwards. Just to stop that. So when you do hit it with a hose, it pushes the seal down and actually closes the seal off instead of actually opening it up if it was the other way around. And then just regular checking. And unfortunately, a lot of seals are replaced, even though the shaft has a little groove or a little ground section where the old seal has damaged it. Yes, the new seal will follow that same position, but it'll also it'll change the profile of the seal and grind it out, and then you'll end up with a leaky seal basically. So just making sure the seal condition is good. If it's a smaller seal, the little speedy sleeves, if you've got damage, a speedy sleeve is a good idea as well, because that gives you a hard, smooth surface, a ground surface to run a seal on. So they're a good repair seal, and they can be used on new shafts as well. They don't have to be classed as a repair seal or a repair sleeve. Sorry, they can be put on a new shaft and protects the shaft, so you don't get that grinding in the first place. And that's easy to just cut off a speedy sleeve and put a new one on and replace it like that. So that will be a more effective seal um, a more effective seal used on that speedy sleeve than on a standard steel shaft, because the steel shafts are normally turned, even though they're turned on CNCs, and they're very fine.
Mm.
It's still a thread that basically is pumping lubricant either in or out underneath the seal lip. So
And I would presume good maintenance procedures, such as making sure that the environment is as clean as possible, seals are lubricated prior to installation and running. We do know that seals that aren't lubricated and then run do tend to wear out very, very quickly. So these are just
yeah,
standard housekeeping
don't
procedures.
don't point your fire
Okay.
hose straight at the seal entry. So,
Yeah, that doesn't that kind of overcomes all the rest of the installation procedures. Is that what you're saying? If you've got a fire hose on it at the end of it, okay.
you've
So
got to
that's
get water in it. So yeah,
all right.
but there
I
are
think
different
we've
types of
covered all
seals.
the questions here. I don't think I've missed one. Um, but thank you very much, Mark. Once again, very informative. You've gone right across the good uh, base on the whole fixed plant equipment within a quarry, small mining site. Uh, I can see a question just come in now about speedy sleeves, uh, shaft tolerance. How does the use of speedy sleeves creates a journal out of specification of the seal manufacturer's shaft tolerance? How does that work? Well, it doesn't, because the speedy sleeve allows you to utilise the same seal diameter, so that's within spec. That's something that's within the seal technology side of it. Um, I'm seeing other questions coming into the webinar chat here. I've kind of missed some of those ones. Does Timken have Australia stock for imperial sizes of TAAs for cotton gins? Mark, can you answer that question off the top of your head?
Yes,
Do
yeah, we're certainly. Yep. Yep,
It's a yes.
TAA.
Okay.
So for everybody else, TAAs is the sleeve. It's an adapter sleeve. So it has a nut, a normal nut on the small end of the taper. It also has a nut, a backing nut on the large end of the taper. So it's actually like a combination between an adapter sleeve and a withdrawal sleeve in one. And the TAAs is our latest design, which we're rolling out into the marketplace and have been in service in different applications. Very easy to fit, simply because the back nut is locked in position at the factory. You drive the spherical until it hits the back nut, and then you've set the internal clearance. So there's no need to use feeler gauges. And in case of the solid box, you can't use feeler gauges, simply because they have the seals already fitted in the factory. So you need to be able to understand and know how much to drive up the taper, the 1 in 12 taper sleeve, to achieve the right internal clearance of the bearing so that you get good life out of it. So,
Right. Okay. Okay. I think we're done. Thank you. I'm seeing lots of people thanking yourself, Mark, for the presentation. Uh,
Roger.
if maybe if anyone's got any ideas, maybe they'd like subsequent presentations on topics, that's always good. If you want to write something down in the chat there, that's always gives us ideas also as to what the marketplace is looking for. We're very conscious of getting good feedback from our customer base and our salespeople to know, markets looking at more information on A, B, C, or D. So that helps us in designing and formulating some of these webinars. So once again, thank you very much to everybody. This webinar will be available via the Motion website. So you may be receiving, I believe, from our marketing department a bit of a survey or feedback on it. So please be nice. But yeah, enjoy your day, and thank you very much for attending. We've had really good numbers here and good engagement. Thank you, Mark, once again, and bye to
Thank you.
everybody.